Welcome to our second video on unit testing, and we're going to look at some more advanced features of unit testing in this video. And in the first example we're going to look at how you can handle exceptions in unit testing. So I've just find a simple function here, divides, which divides x by y. I'll also put a print statement in here so that we can check our progress as we go through the testing, and then we're just going to return x divided by y. So part of unit testing is you should look at extreme values, and in this case y equals 0 is an extreme value because it causes a division by 0, and so is potentially a source of trouble for our program. Alright, so we're going to do a classic setup of a unit test. We've imported unit test, we set up our class divides, and again remember this can be called anything you want, but it is a child of unit test.test case. We have a def in here that begins with the word test. We can put anything after that we want as long as it begins with test. And we are going to check then our divides function using a couple of different examples. So when we divide 4 by 2, we should get an answer of 2, and we are asserting that those answers are equal. And dividing 100 by 3 and asserting that's the same thing as 100 divided by 3, so those certainly should be equal. But then I'm also asking it to divide 2 by 0, and I should get, as a result of that, a zero division error. So here's another sort of assert that you can do, assert raises, that looks for errors. And let's run this and see what happens. So the problem is that I've got 4, 2, so it printed 4 and 2 from this, and then it printed the 2 and a 0 from this divides, but then we got an error, and notice that we never got to this assert equal with 100 divided by 3, so we don't see 100 divided by 3 printed out. So what happened is I passed the parameters 2 and 0 to divides, and we ran into a zero division error, and Python did this division and it caused an error. So that's not exactly the behavior that we want. What we want to do is catch that error and then report back through this process, the unit test, that in fact we did get an error, and it's what we expected to have happen. So in order for, I'm getting the missing white space, the unit testing assert raises process, to catch that error, we actually have to separate out the parameters 2 and 0. So if we pass the parameters 2 and 0 into divides, then Python just runs that as a normal function, divides 2 by 0 and runs into an error, and then tries to pass that information back to assert. That's not what we want to have happen. What we want to have happen is we want the unit testing module to actually run divides, to trap the error by itself and say, yes, we did in fact get a zero division error. So the way you can do this with assert raises, it has a special extra set of parameters that you can pass in. So you can pass these parameters 2 and 0 to assert raises. It will then take those parameters and pass it to divides, and it sort of runs divides on its own, checks for any errors that are raises, traps them, looks for the errors that you want or are checking for, and won't give us a red error down here. So let's run this, and notice now that our unit test ran all the way through, ends up doing the last test, and everything checked out. That in fact we did get a zero division error. And if I run this with a 1 here, then we're going to get our flag back saying, nope, we got an error here. We didn't get a divide by 0. This is a different sort of error than we were getting before. Notice it still didn't go through all the testing. We didn't get to 100 divided by 3, but in this case that's okay because we expected this to fail in this case. We were asserting that we were going to get a zero division error, and we didn't. So there's actually a problem with our code if we were making that assertion that 2 divided by 1 should give us a zero division error, or a problem with our test. So those kinds of flags we expect to have this kind of thing happen. What we don't expect to have happen is that if we are testing something that we want to have happen, that we raise a flag and our testing stops. Okay, so again, In this case, everything should run just fine. All right, so you can also check for errors using unit testing. Now, in unit testing, there is a lot of different terminology. One of the pieces of terminology that you will come across is something called a fixture. When you're running a unit test on a piece of code, you may need more than just the code. So here is an example where I've set up a class, my class. This is not a unit test. This is an actual class I'm defining, where it just has one parameter, and we set self.x to x here. We have a string method where we just return the string of self.x, and then we have a method +2 where we add 2 to self.x. So we're expecting x to be some kind of number. Okay, so now we are going to run a unit test on this, and we're going to test string and +2 to see what they do. But the problem is, in order to run this unit test, we can't just run it on a class. Remember, a class is just an outline for a data structure. It's not an actual data structure. We need to instantiate this thing. So in unit testing, there is actually code that you can use to set up anything that you need to run your unit tests. In this case, I'm going to need to instantiate the class first, run tests on the class that's instantiated, and then when I'm done, I'm going to get rid of any classes that I created. There's special methods, setup and tear down, and then setup, I'm going to create an instantiation of my class, and I'm going to give it x, the value 5. And I'm calling that self.fixture. So this is a fixture to help with the unit testing. And when I'm done with the testing, then it will automatically call teardown, and it's going to delete self.fixture. Alright, so it's going to get rid of this my class. And then down here we're going to test the fixture, and we're going to test +2. So when we run +2, that should give us a 7 because we're adding 2 to 5. And we're going to run the string method on fixture, and that should give us the same thing as string of 5. Okay, so let's run this. And notice the order of things that are done here. So I have a print in setup. So when this is run, we run unittest.main, which goes into the unittest.test case. And the first thing it does is it looks for a setup. So it goes to setup, and it prints out in setup and creates this instantiation with self.fixture. Then it looks for test cases. So it looks for methods that begin with the word test. And you can have more than one, and it will run all those test cases. And we're going to do another video on running multiple test cases. We run this test, and in here we print in test. So we're here. It checks these two things that are equal, and they are, so we pass the test. And then when it's done running all the test cases, we go to teardown, and we print out in teardown, and it deletes the fixture, and which was the instantiated version of my class with parameter 5, and we're done. There's lots of reasons why you might need a setup. If you're testing a class, you might need a setup to instantiate the class. If you have software that's running on a database, then extracting information from a database, for example, then you might need to set up a connection to that database. In setup, you would get the connection set up to the database, and then you could test your code is working. But before you can do that, you need that connection. You might need to establish some kind of FTP connection to another server if you're pulling information from another server. So there's lots of reasons one might need to do a setup here before you can do any actual testing. Depends on how sophisticated the code is that you're testing. In this video, I want to take a look at one more thing, unit testing operators. This is very similar to what we just did. I have my class, which is the same as before, self.x equals x, so it's going to have one parameter. We have a string method, and then I have another operator, equals. And so equals, we're going to check equals with my class in two different ways. If I want to compare an instantiation of my class with just another number, then I'm going to check to see if I have an instance of int, float, or a complex number. And if that's the case, I'm going to compare self.x with that other number. And if other happens to be of type my class, then I'm going to check to see if self.x equals other.x. So this is how I have defined equals for this class. And in any other case, I'm going to return not implemented. And now I want to test to see if equals works. Okay, so we get down here, and again, we're setting up a fixture. So I'm going to set up, in this case, multiple versions of my class. Two of them I'm instantiating with a parameter 5, and the third one with this parameter 6. So object 3 is different from the first two objects. In the teardown, I'm going to get rid of those objects, so that's going to free up the memory where those three objects reside. And then in terms of testing, I want to see if my equals method is working. So I am going to check that object 1 is equal to object 2. And this is in fact all I need to do, because when we assert equal, it's going to look at this object and say, okay, I want to test to see if these two things are equal. It's going to go to this object and say, hey, do you have an equals defined? And it actually will call this. So we'll be testing this just by the fact that we are using assert equal, which will call the equals method. And then we are going to, well, let's just run this as is. So I'm checking to see if object 1 and object 2 are the same. Those should be the same, right? They have the same parameter 5. And in that case, because they are both of type my class, then we will go to this is instance other. Object 2 will be other. And this equals testing. They'll be of type my class, and we'll compare self.x to other.x, and they'll both be 5. In this version of assert equal, we're going to check that self.object equals 5, so an integer, and in equals here, other will be of type int. So this will be an is instance other int. We will come to here, we'll check that self.x, which is 5, is equal to other, and in this case other is just the number 5. And those should be equal. So let's run this and see if that works. And we see that we have, now, we have in setup, then we run the testing. In equals, we have two calls to equals. That's for this assert equal and then this assert equal. So let's print it out twice, and then we do the teardown. And it passes. Both of these, so we get a green. So both of these have passed, and now let's check to see if object 1 is equal to object 3. Remember, object 3 has a parameter 6 compared to an object parameter 5, so those should be different. And in this case, again, the other here will be of type my class. We're going to compare self.x, which will be 5, to other.x, which will be 6. And in this case, the test failed because they are not equal. And so we get an assertion error. And our code is, well, now if we wanted to, and we wanted to run this test, and we wanted to make sure that these actually were two different objects according to equal, then what we could do is run not equal. And if we do that, then we pass. So it can check for equals and say, oh, nope, that's not equal. We're good. Okay. That is installment 2 of unit testing. And installment 3, we're going to take a look at what happens if you have multiple tests that you want to run and have one setup. You always have one setup and one teardown, but you can have multiple tests.